Good afternoon, viewers. Today, I want to speak on some old question papers of CBSE. This may make a few video lessons. This is the first of them. I am taking the question paper of last year, that is July 2025. Its code is 30/S/3. The question paper code is 30/S/3. The first question is, the length of the string of a kite flying 50 meters above the ground with an elevation of 60 degrees is among these four. The length of the string of a kite flying 50 meters above the ground with an elevation of 60 degrees is. Let us look at the picture. So, say we are observing the kite from this point O. That is point of observer. That is the place where the person is observing. And then let a kite be at the point K above the ground. Okay. This line Y is horizontal line. It is line of the Earth. We treat Earth here as a line for this problem's sake. And then the let this kite be above the ground at the point capital E, right? So this KE becomes the height of the kite from the ground, and line segment KE becomes perpendicular to this horizontal line OE. And we are given that the angle of elevation at O of the kite K is 60 degrees. So this angle is 60 degrees. And this triangle OKE becomes a right triangle. This becomes a right triangle because this angle is right angle, that is 90 degrees. We are asked to find the string of the kite, that is OK. Okay, let OK represent the string. We have to find its length. That is, we have to find this h. Let the string's length be h. We have to find h. This is question number 1. Yeah. What is the relationship among these three? We have to find h. We are given this height of the kite above the ground, that is KE, to be some 50 units. And this is angle of elevation. What is the relationship among these three? 60 degrees, h, and 50. So this KE is opposite side of 60, and OK is hypotenuse. So the relationship between opposite side and hypotenuse is formed by the sine of this angle. That is, sine 60 degrees is opposite side by hypotenuse. So therefore, we have sine 60 degrees is equal to opposite side KE by hypotenuse, that is OK. Sine theta, if I call this theta, sine theta is opposite side KE by hypotenuse. Okay. The side in this triangle, the side opposite this angle is KE. So this is opposite side. KE is the opposite side for this angle. And let us substitute the values of KE and OK. KE is 50 units. By OK, let us write small h. Okay. And sine 60 degrees. Sine 60 degrees is root 3 by 2. Sine 60 degrees is root 3 by 2. You have to remember this. So we want h. So let us take h to the left hand side and bring root 3 by 2 to the right hand side. So we have h is equal to 50 into this root 3 by 2. When it comes to the other side, it becomes 2 by root 3. I'm taking h into the left hand side. This is in denominator. It comes into the numerator on the left hand side. And root 3 by 2. when it comes into the right hand side, it reverses. Okay, its reciprocal must be taken. That is 2 by 3, right? Actually, it comes into denominator here. From denominator, but when it enters numerator, it becomes reciprocal. So into 2 by 3. This may, right? Yeah. So 50 into 2 is 100 by root 3 units. This will be the length of the string. So let us look at uh, the choices. Yeah. So 100 by root 3. Height is in meters. So length of the string also will be in meters. So this is 100 by root 3. This is the right answer. A is the right answer. So we have 100 by root 3 meters. This is height of the string. This is length of the string. Length of the string. Okay. Yeah. So this is how we can compute the length of the string. So right answer is A, choice A. Yeah. Let us look at the next question. This is question number 2. Let's take the English part. Yeah. There is a square lawn of side 8 meters inside a circular park of radius 20 meters. Mr. Joseph wants to plant a sapling in the park. The probability that he can plant it outside the lawn is dash. Okay, so we have a circular park. This circle is a park. Inside that we have a square lawn. In square shape, on this park there is some lawn. Okay, some yeah, some meadow. So Joseph wants to plant a sapling in the park. Okay, in this park he wants to grow a plant. Okay, so the probability that he can plant it outside the lawn, yeah, but he wants to plant that he wants to grow that plant outside this lawn, means in this area, right? The area in the area inside this circle and outside this square he wants to plant. He wants to plant, that is, he wants to grow a plant. He wants to grow a sapling. Okay, so we have to find the probability that he plants it outside this. He wants. We want to find the probability for him to plant the sapling outside this square region. Okay, so how can we? So we go for the areas. We find the area of this circle, and then we find the area. Yeah. Huh. See, look at this. There is a square lawn outside 8 meter. There is a square lawn outside 8 meters. So for this square, side is given, that is 8 meters, and radius of the circle also is given, that is 20 meters. So we can find the area of this circle, that is pi r square, where r is 20 meters, and then we can also find the area of the lawn, which is the area of this square, that is s square. S is 8, so s square will be, so 8 square, that is 64 meters square. And then we have to find we have to divide the area of the square by the area of the square circle, that is 8 square meters square divided by pi r square, that is pi into r square, that is 20 square meters square. Okay, let us look at the working. Yeah. So we have square of side 8 meters. So this is 8 meters. This also is 8 meters. and we have the radius of the circle. The radius of the circle. Okay. To be 8 meters. To be how much? To be 20 meters. The radius of the circle is 20 meters. Let me draw it precisely. So, yeah. So I go for this. Okay. Let me draw the radius. So this. Okay. So this radius is given to be 20 meters. This is given to be 20 units, 20 meters. Okay. Let us find the area of this circle. So the let R be the radius of the circle. So we know that the area of the circle is equal to pi r square. This is question number 2. So area of the circle is equal to pi r square. Area of the circle is equal to pi r square. Okay. So this is pi into r is 20 units square. Okay. 20 into 20 is 400. So it is 400 pi. This is the area of the circle. Let us calculate the area of the square. Area of square is equal to s square. If s is the side of the square, then area of this, let this figure be square. So area of this square is s square. So that is 8 square. 8 meters is the length of the side of this square. So area of the square is 8 square meter square. So that is 64. Okay. And we have to find, we have to find the probability for the person to grow plant inside this square region. Okay. Inside this part. Inside this part. Inside this part. Okay. So inside this region, he wants to grow plant. So for the square region, we have to calculate we have already calculated the area, and we have to find the ratio we have to find the probability for him to grow plant inside this park. Means we have to divide the ratio of this square. We have to divide the area of this square by the area of the circle. That is this by this. Okay, 400 pi by 64. So required probability. So required probability becomes area of circle by area of triangle. Area of square by area of circle. Okay, this is area of circle. Area of square is 864 meter square. Yeah, both are this side is in meter, radius is in meter, so we will get meter square here by, we have to take care of the units, and by area of circle, that is 400 pi meter square. Okay, this radius is in meter, so this becomes meter square, and the side is also in meter, so this becomes meter square. So both the areas become meter square, so they get cancelled, meter square by meter square. So these two get cancelled. Okay, so it is 64 by 400 pi. This may be simplified. Okay, let us see. Yeah, the least terms. This is 4 cancels in this. You get 16 here, you get 100 here. Again, okay, so 4 cancels in this. So you have 16 here, and you have 100 here. I'm dividing each of a numerator and denominator by 4. So 4 cancels in 64 for 16 times, in 400, 100 times. Again, 4 cancels in 4 times, in this 25 times. Okay, 425. So what is left is 4 by 25 pi. Okay, meter square cancel. We should not cancel area and area. No. Okay, so required probability becomes 4 by 25 pi. Let us look at the choices. No, no. We have done it wrongly. Actually, he is growing the plant. He is growing the plant uh, outside the park, right? Yeah. Wants to plant a sapling in the park. Okay. The probability that he can plant it outside the lawn. Yeah. Yeah, we have to find the area outside the square. Means this portion. That is, I did it wrongly. So we have to go for the area. Yeah, this portion. We have to subtract the area of the square from the area of the circle. I did it wrongly. I'm sorry. So let me go back. Yeah. So uh, so So I have to subtract. Yeah, no, not this. No, I'm sorry. Before finding the probability, let me go for the yeah. Actually, we are planting. Yeah, we have to find the probability that the sapling is grown outside this square. So we have to subtract. I have to subtract the square of the area of the square from the area of the circle. So I have to subtract 64 from 400. So the area outside park, outside square lawn, outside the area outside uh, lawn in the park becomes what? This is 400 pi minus 64. Okay. Previously I thought he was growing it inside the lawn. No, he is growing it outside the lawn. So we have to find the area outside this square. So here he wants to grow. Okay, in this part he wants to grow. Okay, so we have to find the area outside this lawn in the park. So from park area, we have to subtract the area of the square, that is 400 pi minus 64. Now we have to find the probability that he does this. He cross plant in this area outside the lawn. So we have to divide this area by the total area of this circle. Okay, so required probability becomes this area 400 pi minus 64 divided by 400 pi. Okay, so yeah, let us look at the choices. Okay, it is 400 pi minus 64 by 400. So it is this D, right? So let's come back to the board. Yeah, so this is D. Answer is D. Okay, I'm repeating. We have the area of the circle is given to be 20 meter. So its area becomes pi r square. Substitute 20 for pi r, and it becomes 20 square is 400 into pi. And then go for the area of the lawn. It is in the shape of square. Its side is 8 units. So it is 8 square. Area is s square. Substitute 8 for s. So it is 8 square. 8 square is 64. And side of the square is in meters. So area units for area will be meter square. And the radius of the circle is in meters 2 TW2. So the area of the circle is also in meter square. Yeah. Now he wants to grow the sapling uh, in the park outside the square. So subtract the area of the park, area of the square from the area of the park. Area of the park is 400 pi, and subtract the area of the square, that is 64 units. Okay. And we are trying to find the probability that he grows that sampling in this black shaded region. So we have to find the ratio of this area, that is the area of the region where he wants to grow the sapling, divided by the total area, that is the area of the circle. Okay, that is 400 pi. Okay, it is a kind of this is the for this probability, this is the number of events that are favorable, and this is the number of events of the sample space. That gives you the probability. Okay. Here we are finding the probability that he grows his sapling outside the square in the park. So number of favorable events becomes the area of the region where he wants to grow the plant, divided by the this becomes the number of favorable events, and then a number of events in the sample space becomes the area of the total area, the area of the total park, that is area of the circle, that is 400 pi. Thus, answer is D. Right? Yeah, answer is D. Okay. Well, let's look at the next question. Next question, that is question number 3. The pair of linear equations 9x minus 15y plus 19 is equal to 0, and 5y minus 3x minus 9 equal to 0 represents two lines which are, we know that if this first equation is a1x plus b1y plus c1 equal to 0, and the second is a2x plus b2y plus c2 equal to 0, we have to compare the like coefficients, that is a1 by a2, b1 by b2, and c1 by c2. Okay, let us do that. Here, you should be careful. This is a1 is 9, b1 is minus 15, c1 is 19. But here, first y term is given, and then x term is given. So your a2 is minus 3. B2 is y, and your C2 is minus 9. So let us take these two equations, 9x minus 15y plus 19. This is question number 3. Question number 3. Okay. 9x minus 15y plus something. Then, yeah, let me look at the equations. Nine x minus 15y plus 19, and then 5y minus 3x. 9x minus 15y plus 19 is equal to 0. And the second equation is 3x minus 5y. Yeah, 5y minus 3x minus 9 equal to 0. 5x, 5y minus 3x minus 9 is equal to 0. Let us look at them. So it is 5y minus 3x minus 9. 5y minus 3x minus 9. The first one is 9x minus 15y plus 19. 9x minus 9, 15y plus 19. Yeah. Now, this let us compare. Let us form a1 by a2. Okay, a1 by a2. So a1 by a2. a1 is 9 by a2. a2 is minus 3. This is minus 3. And then b1 by b2 is minus 15 by 5. This is minus 3. And then you go for 7 by c2. That is my 19 by minus 19. Okay, yeah, this is not an integer. Okay, yeah. So you have these two are equal. So this is yeah. Mm, right. So this is equal to a1 by a2. Okay. So means these two become parallel lines. Okay. You have a1 by a2 equal to b1 by b2, but it is not equal to c1 by c2 because this is an integer. This is not an integer. 7 by c2 is not an integer. Okay. It is 9 cancels in this 18 times and 1 remains as a reminder. Therefore, this is not an integer. This is not right, but these two are integers. A1 by a2, b1 by b2 are integers. That's how. That's how a1 by a2 is not equal to 7 by c2, but these two are equal. So that's how this system represents a pair of parallel lines. Okay. Yeah. So there will be no solution. Let us look at the choices. So they are parallel lines. Okay. Answer is C. 3C. Answer is answer is 3C. Okay. Why? Because A1 by A2 is equal to B1 by B2. And each of these is not equal to 7 by C2. Okay. Yeah. What are the other like in some other cases you may have A1 by A2 is not equal to B1 by B2. If in case A1 by A2 is not equal to B1 by B2, then you will have a unique point where these two lines intersect. Okay. These are first degree equations in X and Y. Each of these is a first degree equation. Uh, is a first degree equation in X and Y. So each represents a straight line in the XY plane. So when these two fractions differ, then these represent a unique right a pair of intersecting lines at a single point. Okay, there will be a unique solution for this pair of equations. Okay, but here they are equal. In the situation, all these three a1 by 8 equal to b1 by b equal to c1 by c2. In that case, the given equations represent, of course, here a1 by 8 is not equal to c1 by c2. In some other case, in some problem, you may have a1 by 8 equal to b1 by b equal to c1 by c2. Then the given pair of lines become coincident. Then you will have infinite solutions. Okay, or both the lines represent one and the same. Let us look at the choices and see. how they may work for the other question, other possibilities in other questions or in other cases. Yeah. Okay. Intersecting exactly at one point. That happens when b1 by a2 is not equal to b1 by b2. And then intersecting exactly at 2 points. If they intersect exactly at 2 points, then those two lines coincide. So that B is same as D. Okay. But here, yeah, a1 by a2. a1 is 9. A2 is -3. So 9 by -3 has been -3. And then b1 by b2. b1 by b2 is -15 by 5. That is -3. So that's how a1 by a2 is equal to b1 by b2. And c1 by c2 is 19 by -9. So this is not an integer. That's how you have a1 by a2 equal to b1 by b2 and not equal to c1 by c2. That gives you that they are parallel. Yeah. Let us look at the next question. Capital A -4, 5 and C A2 are two opposite verses of a parallelogram ABCD. Its diagonals intersect each other at point P, AB. The relation between A and B is, yeah. So it is drawn parallelogram ABC. Capital A, B, C, D. Two opposite vertices A and C, -4 by 5, 8, 2. -4 by 5, -4, 5, and 8, 2. Yeah. -4 by 8, 2. The diagonals intersect at PAB, the relation between A and B. Yeah. Mm. At P. A command. Yeah. And so A is equal to 8, 8 plus -4 by 2, that is equal to 4 by 2, that is 2. P is equal to 5 plus 2 by 2. That is equal to 7 by 2, that is 3.5. Yeah. So, 3.5 and so A is B minus 1.5. So you have A is equal to 3.5 minus 1.5, that is B minus 1.5. Okay. Yeah. A is B minus 1.5 means A is so B is A plus 1.5. Yeah, answer is B. So yeah. B is 2 plus 3.5 is 2 plus is equal to 2 plus 1.5. For 2 we can take A, that is A plus 1.5. So that this so answer is B. Yeah. So let us look at the question once again. We are given a parallelogram A minus 4, 5 and C 8, 2 are two opposite vertices of a parallelogram ABCD. If the diagonals intersect at each other at P, A, comma B, then the relationship between A and B is dash. Okay. So how can we, yeah, see here diagonals are intersecting. Right? We have, what are we given? We are given that A, B, C, D is a parallelogram. We have to take these vertices either in the anti-clockwise direction or in the clockwise direction. This is anti-clockwise, this is clockwise. Okay, we have to take ABCD in this direction or in this direction. You may take ABCD this way also. Well, so we are given the coordinates of A and C. A and C are opposite sides of opposite vertices. Okay, and P is given to P, A comma B is given to be the point of intersection of the diagonals. AC is one diagonal, BD is another diagonal. Okay, they are intersecting at the point P. And we are given that ABCD is a parallelogram. What is the condition for the diagonals in a parallelogram? They have to bisect each other. Diagonals bisect. నెమ్మది రికార్డింగ్ లో ఉన్నా bisect each other. నెమ్మది రికార్డింగ్ లో ఉన్నా diagonals bisect each other. Diagonals bisect each other means PB is midpoint of AC and also is the midpoint of BD, the other, both the diagonals. So let us find the midpoint of the line segment AC, right? Its coordinates become the coordinates of P. Okay, the A becomes the average of minus 4 and 8. That is minus 8 plus minus 4 divided by 2. The sum of 8 and minus 4 is 4, divided by 2 is 2. Okay, and then B is again becomes the average of the y coordinates of A and C. So B is 5 plus 2 by 2, that is 7 by 2, that is 3.5. This is because P is the midpoint of line segment AC, right? Then A becomes, if this is x1, y1 and this is x2, y2, A becomes x1 plus x2 by 2, and then B becomes y1 plus y2 by 2. That's how we get the values of A and B. Now, 3.5 can be written as 2 plus 1.5. And for 2, you can substitute small a. So B is a plus 1.5. And B, this relation, B is equal to a plus 1.5 is the choice capital B. Therefore, answer is B. Right? Answer is B. Yeah, answer is B. B equal to a plus 1.5. So with this, I want to end this lesson. So here I try to explain uh, some concepts involved in multiple choice questions of the CBSE syllabus. Okay, I try to explain the concepts involved and various important points involved while solving the questions. And uh, uh, of course, in the second question, I first went in wrong direction, but it may so happen for you also in the exam. Okay, so it helps you how we may get distracted, and again we have to come how to come back onto the right stage, right path. Okay, so with this I want to end this lesson. Happy reading.